Okay, this second video is really going to bump up the intensity for two reasons. One, you'll have problems with division, and then two, you're going to be told to solve for m when really it shows up twice in an equation. So we'll see what that means in a moment. Now, this problem right here says k minus 2 over 5 is equal to 11j. Now this would be less intense if we had to just solve for j, because I could multiply the whole deal by 1 over 11th and that would go away. 1 over 11, excuse me. But because I'm solving for k, I see this as having the entire quantity k minus 2 is being divided by 5. So let's go ahead and rewrite this, even though it's right there, because I want you to see that k minus 2 is really grouped from the bottom, which was just divided by 5. And that whole thing will be equal to 11j. Now we talked earlier on in the semester about how grouping symbols are what happen, and we have to obey order of operations with those. And so this grouping symbol groups the top from the bottom, and never forget that a fraction is the same as a grouping symbol. And that's going to really help me see that when I go by and I multiply both sides by 5, that my 5 will go away in the denominator, and I'll only have k minus 2 left on the left side. And I may as well multiply 11 and 5 to get 55j in this step. K is really looking a lot simpler now. It looked pretty ugly a moment ago, but now this k minus 2 part is a little bit more approachable. Since k has 2 with it, we're going to have to add the opposite, and that'll give me k is equal to 55j, writing the variable first, plus 2. And we'll box that as our answer. About 2 minutes to do that problem and talk about it. That's not too bad. Just make sure that you use those grouping symbols and parentheses as a strategy to help it be more clear to you. Okay, now here's where the intensity gets bumped up a bit. Now let's take a look at this. Well, we have two different things with m. And not only two different things with m, but they're on opposite sides. So I guess I could either try to get this here, or vice versa. And really either way might matter more than the other one later on. We'll see. For my sake today, let's see what happens when I take 2m away from both sides. Well, these go away, and I'm left with negative t, that negative does have to come down, is equal to sm minus 2m plus 5. Well, there's an m here and an m there, but this thing has nothing to do with m, and it's separated by addition or subtraction. So now I'll separate this by subtracting 5 from both sides. Now you have three terms here, 1, 2, 3. Make sure that when you write that minus 5, that it ends up on the left side of the equation. Because moving into the next step, we're going to have negative t minus 5 is equal to sm minus 2m. Well, let's check this out. As a little bit of a side thought, I want you to just put a little asterisk over here and rewrite sm minus 2m. And I want you to realize that s is being multiplied by m, and 2 is being multiplied by m. So both s and this minus 2 are getting multiplied by m. So it's fair for me to write the m on the outside, have parentheses, and show this so that both s and minus 2 are getting multiplied by m. And what we're really doing is we are reversing the distributive property. And you did this earlier on, but it's been a while. So make sure that it's clear that m times s minus 2 would really be the same as sm, or ms, minus 2m. And I show that because this side thought is helpful so that when I go back and I write negative t minus 5 equals m times s minus 2, it doesn't seem as scary. Now, we have this quantity on the left and this thing on the right, but I can't have anything else with m. And even though it's s minus 2, I can divide both sides by s minus 2, so that I now have m by itself equal to negative t minus 5 over s minus 2. That's probably one of the more challenging problems we've done this year. See how they go. If you look these up in the back of the textbook, you also might see it switched around a little bit towards like t plus 5 over 2 minus s or something. That doesn't mean you got the wrong answer. It just means that they've done the negative part slightly different from you. Here, watch me change these signs and you'll see it just match up. So just because you don't match totally the same exact way doesn't mean you're incorrect. So I'm going to scan through this again just so you can kind of revisit what happened. Okay, we got rid of those. We were left with negative t minus 5. We had 3 things on the right. 2 that both had m. We kind of did the backwards way of the distributive property. We call that factoring. And then we divided by something in parentheses, which probably is more challenging than things we've done before. And because of that, let's check out another one. Now here we got d plus 5c is equal to 3d minus 1. And my legs are shaking. I'm getting nervous because I'm seeing something again here. But let's see if this one ends up actually being easier. Okay, now I see the d. Let's move the d to the same side by subtracting d. We also could have subtracted 3d. All that remains on my left side is 5c. And that's going to be equal to 2d minus 1. Ooh, a little bit of a sigh of relief. Because these were like terms, I could just combine them and be left with just straight up 2. So that I could have none of that factoring stuff's really going on here. So I got 2d minus 1. I'm going to move that over. I'm going to add 1 to both sides. And now I'm going to write 2d on the left, just switching that around in my head. And that's going to be 5c plus 1. So again, I'm saving myself the work of having to rewrite it later. Last step here is to divide both sides by 2. And I'll have d is equal to 5 halves c plus 1 half, box it. Also, it's totally acceptable if you'd prefer to write d is equal to 5c plus 1 over 2. Just make sure that 2 doesn't fit into 5 or whatever 1 you have up here on the side. These fractions have to be reduced. And by that I mean if it was 4c plus 2, both of these would be divisible by 2, where I'd have 2 and 1 there. We'll do another example with the whole factoring situation. So I get 6q minus 18 equals qr plus s. And we're told to solve this for q. Right, so in this case, maybe I'll subtract qr from both sides. You can see how I don't really like qr and s here. I mean, this doesn't really present itself nicely. On the left side, I'm going to have 6q minus qr minus 18 is equal to qr. Whoops, that went away, didn't it? My mistake. Is equal to s. And, it's kind of like the same deal. You know how in that last one we just had 3d minus 2d? Or was it 3d minus 1d? I mean, that's the same as saying it was 3 minus 1 times d, wasn't it? So wouldn't this one, if I thought of it as 6q minus qr, isn't that like combining like terms where I'm just saying, well, I have to do 6 minus r, don't I? Because they both share q. Maybe that's another way I can talk about it and think about it. And hopefully that's helpful to see that I can take the q out from both 6 in minus r later on. But before we get there, let's add 18 to both sides. So that I have 6q minus qr is equal to s plus 18. If I think of these as combining like terms, well, they both share a q. That means 6 minus r is going to give me s plus 18. I could also have thought of it as, well, hey, isn't q being multiplied not just by 6, but also by minus r? So 6 is being multiplied by q and by minus r? If these don't feel 100% comfortable yet, that's all right. So I'm looking at this and I'm saying, well, I can get rid of 6 minus r by dividing both sides by 6 minus r. And that's going to leave me with q is equal to s plus 18 over 6 minus r. And per the instructions of this problem, we solve for q. Q is totally by itself. We'll wait before we move on to speed equations and things like that.